Okay, folks. Now, for this second one, if you graph the function, you can use something called the vertical line test. I'm telling you right now, you're going to be talking about this all the way through calculus. Okay? The vertical line test. I'm going to draw a vertical line right here, and I'm going to move it over to the side for the moment. Okay, maybe I'm not. Let me move it down here. Okay? If you're looking at a graph, and you can draw a vertical line anywhere on that graph, and it hits the graph more than one time, it's not a function. Because that means that there's an x that has two different y's. Okay? So look at this one. I'm going to take this, and I'm going to drag it across this graph. Do you see the V graph here in the first one? Yes. Okay? When I drag it across that graph, Cecilia, does it ever hit that graph in more than one spot? It does not. Okay? So this thing is a function, because every x has just one y with it. All right, Cecilia, let's go to the next one. Okay? Now, I'm going to drag this vertical line across the graph. Does it ever hit the graph more than once? No. So it's a function. Okay? Now, let's look at this one. Cecilia, let me ask you this. Is it hitting the graph more than once right now? No, not yet. But if I keep going, I can draw a vertical line that hits it more than once. Is it a function? No. It's not. Okay? Now, if I just drew the vertical line there, would this one be a function? Yes. Yes, it would. But I can draw a vertical line that hits it more than once. In fact, this one hits it 3 times, right? So it's not a function. Does that make sense? The vertical line test tells us if it's a function or not. If it can hit the graph, for instance, right here, it hits the graph here, it hits it here, it hits it here. That's not a function. Okay? For it to be a function, you can only hit the graph one time. Now, let's do this. Parker, I told you earlier that I was going to show you something graphical. Yes. Okay, now I'm not doing example 2 yet. I'm just getting some space so we can talk about this. Imagine that this is our graph. And we're going to say that this is time, like time of day or time during while you're driving. Okay? And this is distance. Okay? The graph could be rate. It could be. We're going to say that this is distance away from home. Okay? Now, when you start out, you're at home, and as time's passing, you're driving farther and farther away. You know, it's not steady, but you're going farther away. All right, so your graph, the distance as time passed away from home, looks like that. Okay? Now, is this a function? Yes. This one's a function. But let me show you something. What does this mean if I drew a graph like this? You're going in 2 different directions at the same time. Well, think about this. Time has passed. So let's say 1 hour after I left home, this and this. Actually, let me move this part up. Here and here. What is this graph telling us? You're going in 2 different directions. No, it's not saying I'm going in 2 different directions. What's it telling me, Kyle?
It's saying that it's like there's 2 different times.
It's one time.
2 cars. 2 different distances.
Yeah, it is 2 different distances. Emily? I'm in 2 places at the same time. I can't be in 2 different places at the same time. Right? So do you see why this is not a function? I can't be in 2 different places at the same time. Okay? So you may say, well, okay, Mr. Cortez, I don't even understand when would you ever have something like that? Well, you might have something like that if the function was the square root of x. Do you agree that if I plug in 9, right, do you agree that I'm going to get 2 different outputs, -3 and 3? Okay? That's one input but 2 different outputs. It makes sense, but it's not a function. All right, let's pick it up on the